Okay. What's the first one? 2 minus 2 cosine. Cardioid. Someone pointed out to me that I have been spelling cardioid wrong all the time. That's how you spell it?
Yeah.
I've been spelling it wrong like this whole time. I missed one of the I's. Cardiad was how I was spelling it. Whatever. All right, so 2 minus 2 cosine theta. Which direction should I go? To the left, cosine. 1, 2, 3, 4. 1, 2. Oh, I'm going to change this one, you guys. Sorry. Let's do on the bottom one. Don't do our sine. Do our cosine. 2 cosine. Sorry. It's a lot easier to solve if they're both cosines. So anyways, here's my cardioid.
We did that on the test.
What? Just
Like switch a sine to a cosine?
You can't do that. I can do that. You can't do that. All right. 2 cosine would be a circle going to the right, diameter of 2. All right. So how many times do these intersect? It looks like we got about 3, right? So 1 up here, 1 down here, and possibly 1 at the pole. All right, so now we just set them equal to each other and solve algebraically to see which ones are solutions. Again, the other reason why you need to do it algebraically is because, I don't know about you, but I can't draw perfect circles. So I don't really know where this is intersecting, right? I mean, is it at pi over 4? Is it at pi over 3? I don't know, okay? So that's why you really want to work it out. All right, move this over. Go ahead, you guys can solve this. All right, when is cosine equal to 1/2? I'm asking such difficult questions. Yes, there we go. Pi over 3 and?
2 pi over 3.
Not 2, that would be sine. 5 pi, let's go 5. Quadrant 4? Pi over 3, 5 pi over 3. Write your answers as ordered pairs. All right, so if I take a pi over 3 and plug it in, I usually like to plug it into the easier one, so I'll do the bottom one. R equals 2 cosine of pi over 3. Well, the cosine of pi over 3 we just said was 1/2. So R equals 1. Same thing here. What's the cosine of 5 pi over 3? Also 1/2. R equals 1. All right, so it's giving me 2 solutions. So now let's check on the graph to see if those are 2 of our valid solutions. Pi over 3 is here. Okay, so my graph is a little off, but it would be along pi over 3, so it looks like it could be about that one if I scoot it in a little closer. And then the other one would be down here at 5 pi over 3 and 1. Yeah, I think I made my heart too hearty. It should have been a smaller heart loop. Okay, but it would be down here a little bit. At least we're in the right quadrant, okay? So what about the pole? The pole looked like it could have been a solution, but in this case, it didn't come out when we solved algebraically. So let's just double check. All right, so when I double check, I plug in 0 for R. I get 0 equals 2 minus 2 cosine theta, and I get 0 equals 2 cosine theta. When I start to solve this, I get that cosine equals 1, and here it's cosine equals 0. Now you could really kind of stop there because obviously cosine equals 0 and cosine equals 1 are going to have different solutions. But just for fun, when is cosine equal to 1? 0. When is cosine equal to 0? Pi over 2 and 3 pi over 2. Are these the same? That's the easy one, guys. No. So since those are different, the pole is not a simultaneous solution. And again, it's that idea of the timing, right? As they're going around, they're intersecting, but they're not intersecting together at the same time. You guys want to see the? Oh, I don't have my calculator. Where did Mr. G take it? Okay. Good? Yeah, Robbie. No, the pole is never going to be 0, 0. Well, it could be 0, 0. It's whatever you get here. Okay, so the R for the pole is 0, but theta could be anything. Okay, so really it's what you solve it for, and then when you plug it back in, you would end up getting an R of 0. Okay, and you'll see some like that, I want to say, on the homework. You're going to see some. Yeah?
So if it was solution, you'd write
0.
Pi over 3 or 5 pi over 3.
Or whatever it ends up being. It could be pi over 4, it could be 2 pi over 7, whatever it is. Okay, you can plug it in. All right, we got 2 more to go. Keep turning the page. All right, this one is pretty easy. Go ahead and try this one on your own.
Why do they make us draw circles at 1.5?
At 1.5, because we want to see how good you are at drawing circles. So 1.5, here we go.
Started in the middle of the 2.
All right, I will work through the problem up here while you guys work through yours. Yeah.
Would you be able to like try and say like, you know how you can say like if you have like a rectangular graph or something, you can say like 1 sec equals 2 or 1 sec equals like 1.5. We do that here too.
Sure, you could change your scale.
Yeah.
Yeah, you can change your scale, but just be careful with the other one. But you could change your scale.
So weird to calculate.
Are you guys going to have to check the pole on this one? Why not? Because the circle doesn't even cross it. So since the circle doesn't even go through the pole ever, you don't have to check.
Anyway, because
No, on this one you really don't need to check it. All right, so go ahead and solve it. See if you get the same answer I do. Because I already knew the answer. Oh, we just solved this one, didn't we?
No, how is that a solution? I'm judging it over 6. Isn't it 5 pi over 6? Whoever came up with
Not for cosine equal to 1/2.
not judging it.
Sine would be 1/2 at the pi over 6s, right?
It's not blue. No.
All right, check your work. Did you guys agree with me or not?
Yeah.
Sure we did. Nice and easy in terms of R this time, right? R would just be 3/2. You don't have to really plug it back in, right? All right, do these two answers correspond with the two we see here? Well, this is pi over 3. It's supposed to be at 3/2, so that looks pretty good. And this is 5 pi over 3. And again, yeah, it looks pretty good. You don't have to worry about the pole since the blue circle doesn't even go through the pole at all. All right, now let's do the fun one. We're going to do roses. Yeah, these haven't been fun yet. Ready? All right, we got 2 roses here. That sine rose. How many petals? 3 petals each. Where does the sine rose start?
30.
Good, it'd be 90 over 3, which is 30. And then what's my spacing? 120, 360 over 3. So my petals would be at 30, 150, and 270. How about for the cosine rose, where would my petals be at? 0. Spacing's going to be the same still, right? So it'd still be 120 and 240. All right, so let's graph them. I'll start with my cosine. 0, 120, and 240. Okay, there's my cosine rows. My sine rows is 30, 150, and 270. Okay. How many potential intersection points do we have? Like a lot. All right, not that many. We've got one here. We've got one here. We've got one here. But remember, these are odd-petaled roses, so their cycle is only pi. So we have to do a full nother cycle in the domain from 0 to 2 pi. So then we would intersect at those again. So we could have 6 there. But then you guys are forgetting about the pole. So how many times do we go through the pole in a cycle and then do a whole nother cycle? We could have a lot of potential answers here. All right, so let's do the actual work and see how many we have. This is so fun because I'm kind of a nerd. If you haven't figured that out yet. All right, these are gone. I have the sine. Let's do a u substitution right away. Oh, we just did this. When is sine equal to cosine?
Pi over 4.
And?
5 pi over 4.
Very good. All right, so it's only when we're at the root 2 over 2's or the negative root 2 over 2's. Since it's a u substitution, I have to generate more. Add 2 pi. What do we get?
9 pi over
9 pi over 4 here. And 13. Add another 2 pi because this is u is equal to 3. So this would be what, 17? All right, so how many solutions are we going to have? There's going to be 6, yeah. When I plug back in the 3 theta and divide everything by 3, and then I write out all my answers. All right. So pi over 12, 9 pi over 4 over 3, that actually simplifies to 3 pi over 4, 17 pi over 12. In my next line, 5 pi over 12, 13 pi over 12, 21 pi over 4 simplifies to 21 pi over 12 simplifies to 7 pi over 4. All right, so those are all of your thetas. We have to plug them back in to get r. Don't freak out. It's really not that bad. If you plug in this first one, pi over 4, you're going to get the same answer for the 9 pi over 4 and the 17 pi over 4. Right? Those are the exact same. It's one revolution. So you're going to get the same one. Okay? So when I plug these back in, bear with me for 2 seconds, you're going to get root 2 pi over 12. And then these ones will also be root 2 for that one and for this one. Okay? Sorry, close parentheses. These ones will be the same, but it's going to be negative root 2. Okay, so did the pole come out at all in this answer? No, the pole did not appear. The pole is not a solution. But you could check it by plugging in 0 for r. All right? And what you'll notice is that the sine and cosine, these are going to be different. So the pole, goodbye, is not a simultaneous solution. And these are your 6 answers. You can check them on the graph. They do all work. You get 6 solutions for this one. You guys all need to go to bed early tonight. I saw a lot of droopy eyes out there. I know this is not exciting stuff, but go get some sleep. I love you all. Go to sleep. Go to sleep. Go to sleep. Go to sleep. You have 2 pages of homework in your practice packet. Oh, I'm still recording.
Yeah, I know.
Stop recording.
Yeah.